Okay, in this video, we are going to find the volume of a shape. So the region in the first quadrant between the curve y equals negative x squared plus 10 and the curve y equals 0.5x cubed is rotated about the y-axis. Find the integral for the volume of the resulting solid. You do not need to actually compute the volume, but you may use your calculator to find the intersection point. So let's decipher, what is this trying to get us to do? What type of solid is this trying to have us make? So it says is rotated about the y-axis. And so that tells me that we are going to rotate right here. We're going to rotate around like that. And if we rotate around like that, this is the region that is bound by that y-axis and then has that point of intersection. And so it's going to be important that we know what that point of intersection is, but let's not worry about that right now. Let's try to draw out this shape. So the top is going to be this parabola here, and then the bottom is going to be like this. It's kind of like a football. That's not exactly right. This should be more rounded, I think. I guess I could make it more rounded. Like something like that. And then, of course, this is 3D. This is 3D, so imagine something like this, and this would be kind of the center of it, and pretend like we are looking at a cut section in the middle. So there's the center of it, and then of course you could make little discs here. So ultimately what we want to do is we want to find the volume of this shape. So to find the volume of this shape, we can make perfect little cylinders or discs. So we can make perfect little cylinders or discs in here. And so we're going to make a little cut section here. And here's my cut section. And what you'll notice is that the height of the cylinder is where, let's call it dy. It's going to be in terms of the y-axis. And in order to find the volume of a cylinder, you need to know the area here, and then you need to know the height. So the area of the circle times the height is going to give you the volume of a cylinder. So the volume of a cylinder, to find the area of a circle, it's pi r squared. And then we're going to multiply it by height. So that'll give you the volume of this little cylinder. Now we can cut infinite number of these cylinders all the way through this. And the thing that's going to be changing is going to be your radius. Your radius is going to be changing dependent on the equation that you're using. And so on the top half, our radius is changing differently. So on the top half, our radius is changing differently than it is on the bottom half. And so I'm going to cut this shape into two. I'm going to cut it right here. And if I cut it right there, I really do need to know what that intersection point is. And so let's go to Desmos and see, what is that intersection point? They intersect right here. And so that intersection point is 2.186 and 5.222. So let's go ahead and write that on there. This point is 2.186 and 5.222. Okay, I think we have enough information to integrate now. Or to set up the integral, not to integrate, but to set up the integral. So let's start with this bottom piece, and let's call this bottom piece piece 1. And so this bottom piece, the radius is going to be changing with respect to this equation here. So these are going to be each of the radii of this equation. And because we are integrating with respect to y, because we're making all the heights in dy, we need to make sure that our equations are in terms of y. So this equation here is going to be the positive cubic one. And so we need to get that positive cubic function in terms of y. We are going to divide by 0.5. Dividing by 0.5 is the same thing as multiplying by 2. So we're going to have 2y equals x cubed. And then we're going to take the cubed root. So x is going to equal the cubed root of 2y. So all I did so far was I took this equation and I put it in terms of y. Let's go to Desmos and just double check, did we do that correctly? So we're trying to figure out if we rewrote the blue line correctly. And what we said we had was x equals 2y to to the power of 1/3, or the cubed root of 2y. And what I notice is that that line does fall directly on top of the other one. So I know that I rewrote it correctly. So now it's a matter of writing that piece of the integral, because we need this first piece, and then we'll need to find the second piece, and let's do the second piece in a different color, and then we'll add them together. So this integral is going to be pi times the integral of 0 to, we're integrating with respect to y, so we're going to go to here, 5.222, nearest hundredth, that's thousandth, so actually let's just do 5.22. So we have the pi out front. Now we need the radius. We just figured out that the radius is the cubed root of 2y, and we are going to square that because it's radius squared. dy is our height. So that's going to be the volume of the bottom piece of this. Now we want to find the volume of the top piece and add them together. So the volume of the top piece, again, we're going to start with pi, and now we're going to integrate from here to here. And let's go to Desmos and just make sure what that y-intercept is. And the y-intercept is 10. So we are going to integrate from 0 to 10. We now need this equation in terms of y. So we have y equals negative x squared plus 10. I'm going to subtract 10. I'm going to divide by -1, and dividing by -1 is the same thing as kind of rearranging these. And then I'll take the square root. I'll go back to Desmos and make sure that that is correct, that that really is equivalent. And so I'm going to say x equals the square root of 10 minus y. And it looks like that line, let's change colors to make this a little bit easier to see. Let's make it green. That green does fall directly on top of the piece of the red that we wanted. So now we'll just follow this equation. We have the pi. We know what our r is. We're going to square it, and then dy is our height. Now, we could try to simplify this. If we were to try to simplify this, the only piece that really would simplify is this here, and then we could take a pi out front. So to simplify it, we could say, well, pi times the integral from 0 to 5.22 of the cubed root of 2y and then squared dy plus the integral from 0 to 10. I'll no longer have the pi there because I factored it out front. 10 minus y dy. And this equation here, this integral, would get the volume of that shape. And the question doesn't actually ask us to find the volume. It just asks us to set it up. And so we're done. So a couple of things for this question. One, there are two pieces of this. There are the bottom piece and the top piece. It's important to break them up into the bottom piece and the top piece because they are changing by different, the radius is changing by a different rate. And then because we drew the height in this direction, in the y direction, you have to get everything in terms of y.